This is 7.4, solving polynomial equations in factored form. Factored form is when a polynomial is written as a product of factors. So we see standard form would be a regular polynomial. Factored form, we would have x times x plus 2. If I were to distribute this, I would get x squared plus 2x. Similarly, I could have x minus 3 times x plus 8, and then if I FOIL it, I'll get my polynomial. We have the zero product property, which says if a product of two real numbers is 0, then at least one of them is 0. Because anything times 0 is 0. So to equal 0, one of them has to be 0. So if I have a times b equals 0, then a equals 0, or b equals 0, or both. And then we have roots, which are the solution of a polynomial equation. It's where the graph of the polynomial would cross the x-axis. So let's do a few examples. If we solve each equation, 2x times x minus 3, one of them must be 0. So I'm going to split it into two different equations equals 0. Solving the left, I get x equals 0. Solving the right, x equals 3. If I have this one, split it into 2, solve the left and x equals 1, solve the right and x equals 6. Here's another one. X times x plus 5, either x is 0 or x plus 5 is 0. So x could be x is 0 and x is negative 5. Solve this one, and you get x equals negative 3 and x equals 4. We have something called related roots, which is when two or more roots of the equation are the same number. So here, if I have 2x minus 5 times 2x minus 5, that's the same thing. So I'm going to have repeated roots of x equals 5 over 2. Because they're exactly the same. But if I have x plus 3 times x minus 3, I would get two different numbers of x equals 3 and x equals negative 3 and x equals 3. Negative 3 and 3 are different numbers, so they are not repeated roots. If I have three binomials, I would set each of them equal to 0 and solve for x. So I get x equals negative 3, x equals 2, and x equals negative 4. I hope you remember the greatest common factor is the largest positive integer that evenly divides each of the numbers. So between 56 and 64, GCF is 8. 8 is the largest number that you can divide each of these by and still get a whole number. Between 2x and 3x, that's 2 times x and 3 times x. So the greatest common factor is x. If I have 3x and 18x, greatest common factor is 3x. So we can factor some of these polynomials. If I have 4x to the 4th plus 24x to the 3rd, I'm going to make trees, little factor trees that show what each one is multiplied by. So 4 times x to the 4th is 4x to the 4th, and 24 times x to the 3rd is 24 and x to the 3rd. Now I don't have anything in common yet, so I'm going to split them apart again. I'm going to split this x to the 4th into x times x plus 3, or x to the 3rd. And then 24 can be 4 times x. Now I have a coefficient in common and a variable term in common. So I'm going to take what they have in common and put it on the outside of the parentheses, and then all leftovers from 4x to the 4th go in its spot. Leftover was x. Leftover from 24x to the 3rd was 6. Because what they had in common went on the outside. Now if I solve that, I would have 4x to the 3rd equals 0, and x plus 6 equals 0. So x would be 0, or x would be negative 6. factoring this one, I would get x times x and 5 times x. So then I would have x on the outside, because that's what they have in common. Leftovers on the inside. Leftover from x squared is x. Leftover from 5x is 5. So x equals 0 and x equals negative 5. And one more. If I have 4x squared equals 2x, I want it to equal 0. So I'm going to move the 2x to the other side. So 4x minus 2x equals 0. Then factoring these, I can see that I have a 2 and an x in common. And I have a 2 and an x. So 2x goes on the outside. And then leftovers from 4x squared are 2 and x. It's minus, so that goes in the middle. And then I didn't have any leftovers here, so that is a 1. Because 2x times 1 is 2x. Then that equals 0. Then if I solve, I get x equals 0 and x equals 1/2.